Algebraically Calc, this lesson is going to involve solving with the zero product property. The first thing we have to make sure we know, okay, is that a product means that two things are being multiplied. Two things are being multiplied, okay? And it's super important, where's that red pen, okay, that we mention this is called the zero product property. It only works with the number zero. For example, something times something makes zero. Okay, I know for sure either in this set of parentheses there must be a zero, or in this set of parentheses there must be a zero. There has to be. That does not work with adding, right? If we have something plus something make a zero, neither of these have to be a zero, okay? So we're talking about the zero product property. Quadratic means that the equation has an exponent or a power, okay, of 2. And what that means is we're going to get two answers. Two answers. If you have a power of 2, there's going to be 2x equals answers. Okay? And what are the steps to solving a quadratic equation? Okay, number 1, the most important step is you move all terms to one side to make the equation equal 0. Everything has to get over to one side. If you have terms on the left side and the right side, move everybody over. Step 2, you factor. You go ahead and you factor the equation, okay, into a product so that it's something times something equals 0. Step 3, set each factor equal to 0. If you have two factors, then you have something equals 0, something equals 0, okay? And then solve each mini equation. Solve each mini equation, okay? We're going to go through the different ways you might see a quadratic. Okay, so for example, this first equation right here, I notice only has two terms. So a quadratic equation could come in the form ax squared plus bx plus c. Okay, and we could have three terms, a power of 2, power of 1, and then the constant. But I noticed here there's only 2. Okay, so this example is when there are two terms. Now I already have the 0. And step 2 is to factor. Okay, I don't need to do an MA table when there's two terms. Okay, I'm just going to factor out a GCF. The greatest common monomial here is going to be a 5x, leaving us with x minus 2, okay, equals to 0. Now I do have a product. It's this term times this quantity. If you like to put parentheses around this, you certainly can. You don't have to, but it is a product. Step 3, set each factor equal to 0. So either the 5x is equal to the 0, or the x minus 2 is equal to 0, and then we solve each mini equation. I've got x is equal to 0, or x is equal to 2, and these are the two answers. Okay, so when you have a quadratic, there might be two answers, okay, and I can show you why this works. If we go over here and check, I'm going to try 0. If I plug 0 into the x spots, that would give me 5 times 0 minus 10 times 0. Does that equal 0? Yes, 0 minus 0 does equal 0. I think the other answer is 2. So let's plug 2 in. 5 times 2 squared is 4, minus 10 times 2. Does that make 0? Let's see, 20 minus 20. Yes, that does make a 0. These are the two answers that solve this equation. All right, let's take a look at the next one, okay? This one also, let's notice here, also has two terms. Okay, so this quadratic only has the quadratic term, okay, and then the constant. But I have step 1, it's already equal to 0. Step 2, factor. Okay, the factoring does get a little bit easier here. I'm going to factor out a 4. And that leaves us with x squared minus 5. Okay, Can I factor further? Yes, because it's a difference of squares. I can. Okay, so we're going to have two sets of parentheses. We're going to have plus and minus, and then what do I do here? If that was a 9, I'd say 3 and 3. If that was a 16, I would say 4 and 4. Okay, so what are we supposed to do? We're supposed to square root that number, and we get plus and minus the square root of 5. All right, now we set each factor equal to 0. And we don't have to say 4 equals 0, because it doesn't. Okay, set each factor, let's just put a little note here, with an x equal to 0. Okay, so the only factors I have to worry about are x plus radical 5 equals 0, x minus radical 5 equals 0. So my solutions are negative radical 5 and positive radical 5. Okay, let me show you another way we could possibly solve this. Some people like to solve it like this, and this is perfectly acceptable as well. Let's write it down again. Okay, since this is a number, you can solve this quadratic. There's only one x term. It was different when you had two x terms. Okay, you can go ahead and move the 20 to the other side since it's a number. We could divide both sides by 4. Okay, we're going to get the same answers. I'm going to go ahead and square root both sides. The way that you undo a squared powers with a square root, they cancel. Okay, but please do not forget that when you square root, when you have a variable, you get plus and minus the answer. Okay, plus and minus. Let's just put that little note here. Plus, okay, plus and minus when we square root a variable. Okay, when you're solving with a variable. Okay, but notice we got two answers and it was a quadratic. This next one right here, okay, finally we have a 3-term equation. It's a quadratic with 3 terms. Let's just write that down. This one has 3 terms. Okay, and so the factoring is going to get a little more fun. Okay, so let's factor with an MA table. Let's do some factoring. So I'm going to go ahead and multiply the leading coefficient times the constant. The multiply number is negative 28, and the add number is negative 3. I don't really think about the negatives at first. I'm just going to figure out how to make it 28. But they have to add to 3. So is it 1 times 28? Is it 2 times 14? Is it 4 times 7? Yes, it's 4 times 7 to make a 3 by subtracting. Now let's think about the negatives. One of them needs to be negative to multiply to a negative, but when they add together, they have to make negative 3. And I'm going to put the negative on the 7. Okay, I found the numbers. All right, what are you supposed to do with those numbers? You split the middles. So x squared, okay, gets written down. And then instead of negative 3x, I'm going to write these guys. Plus 4x minus 7x minus 28. Okay, is that good? Oh, no, we have to write equals to 0. This was an equation. I want to make sure I keep it an equation. Have to write the equals 0. We're doing the zero product property. From the first group, let's take out an x. That gives us x plus 4. If it starts with a negative, what are we supposed to do? Factor out the negative 7, giving us x plus 4. Okay, did you write equals 0? I hope so. I see matches, so this is definitely working. X minus 7, x plus 4 equals 0. Okay, so in terms of our steps, I had everything on one side. Step 2, factor. Okay, so we've only done steps 1 and 2. Now it's time for step 3. Set each factor equal to 0. X minus 7 is 0. X plus 4 is equal to the 0. And so my solutions are positive 7 and negative 4. Okay. Please don't just take these numbers here and say those are your answers. Those are the numbers that we use to split the middle Okay, they were a little bit related this time to our answer, but they're not the solutions. Okay, we're getting good at solving. On the next page, it looks like this quadratic equation. Okay, when you see a power of 2, that tells you there's going to be two answers. Okay, let's find them by doing the zero product property. First thing we have to do is move everything over to one side, and let's write it in descending order. Power of 2 goes first, power of 1. When I switch sides, I have to switch signs. Okay? And don't forget to write equals 0. It has to be an equation in order to solve it. If it doesn't have the equal sign, don't add it. If it does have it, don't lose it. Okay, the next thing we have to do is figure out how this factors. Okay, so please take some time and tell me how that factors. Okay, so if you use the guess and check technique, or if you use the MA table, you definitely had to get a 2x and an x. Okay, and then we're going to get 35 is probably a 7 and a 5. Okay, so if I put the 7 here, and I put the 5 here, let's just go ahead and check our firsts work. Our outers make 14. Let's make them be negative 14. Let's make the inners be positive 5, and that one make negative 9, and your last would work. Okay, if you needed to do more work with an MA table, I hope that you did that. Okay, the factoring part is going to be the hardest part. Step 3 is to set each factor equal to 0. Each factor could possibly equal to 0, and then we solve them. So right here, I've got a negative 5, and then divided by 2. And over here, we have a 7. And those are our two solutions. Okay, could you check a solution to see if it works? Absolutely. You could take the number, plug it in for the x, and see if it makes 35. Does 2 times 49 minus 9 times 7, does that make 35? If it does, then it checks. Okay, solve algebraically. Okay, I notice here that there's a power of 2. When it has a power of 2, that means that we're going to get two answers. I notice that we only have an x squared term. Okay, so we don't necessarily need to factor this because it's x squared equals. Okay, so what I'm going to do is square root both sides. The squared cancels with the square root, and you just get x. And then what does x equal? I hope you said plus and minus radical 17 because we said two answers. Could you have factored this? Sure. You could have moved the 17 over to the other side, and using a difference of squares, you could definitely factor this into x plus and x minus. And then remember, what do you do to that number? If that was a 16, we'd say 4 and 4. You would square root it, and that's exactly what you have to do here. Okay, so you would get plus and minus radical 17 either way. All right, this next one's getting a little more fun. I notice here the highest power is 3. Okay, so what that tells us is there's going to be 3 answers. 3 answers. I already have equals to 0. Okay, and what kind of factoring is a problem like this going to have? All right, we are going to solve it by factor with grouping. And you have 4 terms, okay? You could do factor with grouping. If you need to underline the 2 groups, go ahead. Okay, do not put parentheses because we're not making a multiply. If you want to highlight them, go ahead. From the first group, let's take out x squared, leaving us with x minus 2. Okay, from the second group, if it starts with a negative, you have to take out a negative. Remember, you have to say plus or minus something. I'm going to say minus the biggest number we could take out here, 2. We could take out a 4. We could take out an 8. Ooh, go even higher. Take out a 16. Take out a 16. And that leaves us with x minus 2. Don't forget to write equals 0. Okay, I could tell it's working. So one set of parentheses is going to be for the factors that you took out, or the leftovers, x squared minus 16. And the other set of parentheses, okay, is your matches. Now hang on. Are we done factoring this? No, we're not done factoring. Okay, we have to factor this difference of squares. So there's one more line of factoring. X plus 4, x minus 4, x minus 2. Okay, did you write x equals 0 here? I hope so. Okay, are we done factoring now? What about this one? Can we factor this one more? No, because he doesn't have a power. They're all single x's. Okay, we had x cubed. We have 3 factors. We said 3 answers. Okay, and here they come. Here they come. X plus 4, u equals 0. X minus 4, u might equal to 0. Or x minus 2, u might equal to 0. Each factor has an x. Okay, remember, when it was just a number, we didn't have to worry about it. So our solutions are negative 4, positive 4, positive 2. Let's put a box around those. Okay. All right, the last thing really isn't solving. This is factoring, but I definitely want to go over how to factor a difference of cubes with you. Okay, a difference of cubes. So difference means that there's a subtraction sign. Okay, and a cubic means that it came from the same number 3 times. X times x times x. And then 27 is what? 3 times 3 times 3, right? I recommend that we write this as the cubes. Okay, so step 1 is find the cubes. Find the cubes. 27 came from 3 cubed. Okay, now step 2. Step 2, okay, there's going to be the little guy. There's going to be the little guy, okay, and then there's going to be the big guy. And here's how you make this happen. Okay, equal sign. Little guy, big guy. The little guy, you just take the factors x minus 3. Okay, so this one kind of looks like the problem. Okay, with the factors. Now the big guy, okay, he needs 2 of each. He needs 2 of each. Let's just put that in quotes, and I'm going to show you how to do this. Okay, so first I'm going to take x. I'm going to say x times x is x squared. Okay, to make the end, I'm going to take 3 times 3 and say 9. But to make the middle, I'm not going to take 2 x's, and I'm not going to take 2 3's. I'm going to take 1 of each and say 3x. Okay, 2 x's, x times 3, and then 3 times 3. Okay, and then here comes the fun part. Here comes the fun part. Step 3, you're going to sop it up. Sop it up. And what does sop stand for? Okay, the first sign is going to be the same. You see how it's a minus sign and a minus sign? Okay, so it's going to be the exact same as the problem. The second sign is the opposite. So not a minus sign, people. Let's put a plus sign. All right, and then P, the very last sign, is going to be a positive sign. A positive sign, or sometimes people call it a plus sign. Doesn't matter. It's always a positive. Okay. Is there a way to figure out if this is correct? Well, absolutely. Okay. We can check by multiplying things out. Okay. Let's go ahead and check to make sure this does work. If I multiply x times x squared, that makes x cubed. Perfect. Then let's give the second term an x, so that's 3x squared, and let's give the last term an x plus 9x. All right, x, you're done. Let's go ahead and distribute the minus 3. Minus 3x squared, minus 9x. A negative 3 times 9 is going to be minus 27, okay? And notice how the middles both cancel out, and we're just left with x cubed minus 27. So it does check. All right. This technique, okay, also works with the sum of cubes. It also works with the sum of cubes, okay? When you're factoring difference of squares, okay, like we did up here, you could only do it with a minus sign for quadratics, okay? But cubics, you can do differences and sums like we did here. Let's go through the steps. Okay, so first let's find the cubes. X is clearly a cubic. That's x, x, x. And then, is 64 a cubic? Yes, because that's 4 times 4 times 4. So that's 4 cubes. We found the cubes. You need to know where these things came from. Okay? Equal sign, a little guy and a big guy. The binomial and the trinomial. Okay, so the binomial looks like the problem. Looks just like the problem, x plus 4. Okay, and then how do you make the big guy? We need 2 of each. Okay, so don't even look at these powers. I need x times x. That makes x squared. I need 1 of each. 4 times x. 4x. I need 4 times 4. 16. Okay, don't worry about the signs. We'll do those later. Just get the terms written down. Okay, and finally, sop it up. Sop it up. So I know the first sign looks like the problem, plus. The second one is opposite. Don't put a plus, put a minus. And the last one always gets a positive. Okay. Can you solve an equation by factoring? Okay, and not only factoring, but we did the zero product property. Okay, I hope so. And second thing, can you square or square root both sides? Yes, we can. Good job, guys.